All right, College Algebra 3.1 homework. First problem gives us an equation for a parabola, and it wants to know where the vertex is. There's two different ways to do this. I'll do the easiest way first, and then I'll do the other way, which is a little harder, but I think it's good to learn because we're going to have to complete the square when we do conic sections later. So I would learn both ways if I were you. But the first way is, on our formula sheet, we have the x-coordinate for the vertex is at negative b over 2a. So that'd be negative 6 over 2 times negative 1, which is just positive 3. That's the x-coordinate for the vertex, so that's h. And then to find the y-coordinate for the vertex, I obviously have to plug this back in. If I do that, I get negative 9 plus 3 times 6 is 18 minus 4. So that'd be 9 minus 4, which is 5. So that's probably the easiest and quickest way, is to just use the x-coordinate for the vertex. Once you find it, plug it back in to find the y-coordinate of the vertex. The other way is to put it right in the vertex form by completing the square. To do that, what you do is you take this parabola, you make sure that a is 1, so you change the sign on everything here to make sure that a is 1. Then you move the c over, so you subtract 4 from both sides. And then you complete the square. So you add b over 2 squared to both sides is how you complete the square. So b over 2 in this case is negative 6 over 2, which is negative 3. So I'm going to add negative 3 squared to both sides, which is really just 9. This gives me negative y plus 5 equals, now when you complete the square, this becomes a perfect square trinomial, so it becomes x minus 3 squared. Put this here and this here basically. You subtract 5 from both sides, and you multiply through by a negative 1, and what you get is this, which is the same parabola but now in vertex form. And in vertex form you can easily see x minus h squared plus k. You can see that h is 3 and k is 5 that way. There's vertex form. So completing the square is not something you're going to have to know how to do for now, but later in this class you will. If you want to do it now, that'd be fine. Okay, next problem gives us a parabola, gives us 2 points. It tells us it has a vertex at this point, so that's our HK. And then it tells us another point is 0, 0. I would plug this in right into vertex form. And we know that h is 2. We know that k is 2. So we're going to now plug in 0, 0 for our point xy. And we're going to find a. Okay, when you do this, you get negative 2 squared, which is 4. So you have 4a. I'm going to move the 2 over as well, and then divide by 4. And you get a equals negative 1/2. Now, my answer is just what you get when you plug this back in. So this would be y equals negative 1/2 times x minus 2 squared plus 2. That's my equation in vertex form for the parabola. All right, this problem is going to be pretty tough. I might have to end up making this extra credit. We'll see how it goes. But the first point here, well, actually, you know, I won't make this extra credit because you can just enter in what I do here. But it's really good practice. So if you can do this on your own without watching me do it, that'd be good. So the x-coordinate for the vertex is negative b over 2a. We know that. So that goes here. Negative b over 2a. The hard part is when you plug this back in. When you plug this back in, you get the y-coordinate, which is what we need to put here. So we need f of this negative b over 2a. So when we plug that in, we get a times negative b over 2a squared plus b times negative b over 2a plus c. Now we just need to simplify this. So this would be a times, double negatives cancel when you square this, so you get b squared over 4a squared plus here we get negative b squared over 2a plus c. And I don't know if they would accept this answer if I enter it in. Obviously I can simplify this a little bit here if I cancel the a with one of these a's. So I get b squared over 4 plus negative b squared over 2a plus c. I'm going to enter that in here and see if that works real quick. And I was not able to accept this answer, so I'm going to have to try to simplify this some more, combine these terms and see if that works. Assuming I didn't make a mistake here, which I might have actually, because there's still an a in the bottom here. So let me try that. Yeah, that works actually. I know it's a little difficult to type in. I put everything in parentheses, top and bottom of these fractions, and but I did forget this A originally. So it does work. We don't have to simplify it anymore. All right, next problem is just a simple simplification problem. Boil it out. You get 18t squared plus 12t minus 30t plus negative 20 plus 6t minus 4. And when you add like terms together, you get 18t squared. Now I'm going to add the t's together. 12 minus 3 is a negative 18, plus 6 is a negative 12t. And then I have some numbers, so negative 20 and negative 4 make negative 24. So we can enter in A, B, and C now. All right, the next problem then is a parabola. It's shifted, and they want to know how it's shifted. So we're going to reflect this thing over the x-axis, so we're going to change the sign on y. And changing the sign on y, we can put it over here. And then we're going to move this thing to the left, 1, 2, 3. So that'd be adding 3 to x. And then we're going to shift it down 1, so we'll be subtracting 1 outside here. So that should be our formula to represent this new parabola transformed from its parent function, y equals x squared. Yeah, this is just a different problem for number 6, just to try to help you think outside the box, maybe a little creatively about vertex form and standard form. They give us the vertex in this case, and we actually know what A is because A is right there, right? AX squared plus BX plus C. So A is negative 18, and the vertex is negative 3, so it'd be x minus negative 3, which is x plus 3, squared minus 1. So that's my function. Now they want us basically to give me B and C. Well, I won't know those are unless I FOIL this out and put it in standard form. So that's what we're going to do. When you FOIL this out, you get x squared plus 6x plus 9. And I need to distribute the negative 18 to everything now, which is negative 18x squared plus negative 108x minus, or plus or minus, doesn't matter, 162 minus 1, so that'd be negative 163. So there's your A, your B, and your C, and they want B and C, negative 163 for C. Okay, next problem gives us a polynomial, a quadratic polynomial in standard form. It wants us to put it into vertex form. Now, one way to do this is, you know what A is 2. And you know how to find HK like we did before, because H is negative B over 2A, and then you plug that into the polynomial to get K. And so once you have that, you can plug H and K in. And that works fine. I'm going to complete the square though, because like I said, it's good practice for coming up, and I don't think it's that much harder. So to complete the square, you need to first get A to be 1. So I'm going to divide everything through by 2. This gives me y over 2 equals x squared plus 4x plus 7. I'm going to subtract 7 from both sides. And now I'm going to complete the square. So now I'm going to add something to both sides to make this a perfect square trinomial. That something is always b over 2 squared. Once you get a to be 1, that is. So b is 4, so 4 over 2 is 2. So 2 squared is what I'm adding to both sides. That's really 4. So this becomes y over 2 minus 3 equals x squared plus 4x. I'm sorry, this factors into x plus 2 squared. That's a perfect square trinomial. And then I can add 3 to both sides, and I can then multiply everything through by 2 to get rid of the 2's. And when I do that, I get this answer right here. So A would be 2, H would be negative 2, right, because this is x minus H, and then K would be 6. Next problem gives us a parabola. I'm going to write this as negative x plus 3 squared plus 9, like this. So I just flip these two terms. I can see it's a parabola that opens down, and I know it goes through the point HK, which if I write this as x minus negative 3, you can see that H is negative 3, and K is 9. So my vertex is there, and we know it opens down. So the vertex is negative 3, 9, and it has to be a maximum because we know this parabola goes through negative 3, 9, but opens down. Next problem wants us to find the x and y intercepts. So of this parabola, we know this thing opens up and it's shifted down a little bit, and it's shifted down 9 units, but it's been stretched vertically as well. So to find the x-intercepts, you always do the same thing, right? Because x-intercepts are always where y is 0. So plug in 0 for y and solve this equation. Then we would add 9 to both sides. We would divide both sides by 3, so you get x squared equals 3. Square root both sides, you get x equals plus or minus the square root of 3. So the x-intercepts, they want them as ordered pair. So I'll do positive square root of 3 comma 0 and negative square root of 3 comma 0. And the y-intercept then is where x is 0. So now, think about the y-intercept, that's where x is 0, and it's down here. So plug in 0 for x and you get negative 9. So that'd be 0, negative 9. And then the range, we know if this parabola goes through, it goes through like this, where this is negative 9, this is positive square root of 3, and this is negative square root of 3. This is 0 comma negative 9, if I want to give it as an ordered pair. We know that this thing goes up, so that the range is going to be all real numbers above negative 9. You could say that as y has to be greater than or equal to negative 9, or they want it as an interval, so it'd be negative 9 to positive infinity. We can include negative 9. Another problem with vertex and x-intercepts. Vertex is at negative b over 2a, which would be, in this case, negative 19, which is positive 19, over 2 times 3. So it would be 19 over 6. And then I have to plug that back in, which I know is a lot of work. You can use your calculator for this if you want. But it's 3 times 19 over 6 squared minus 19 times 19 over 6 minus 40. If I do that in my calculator, that gives me negative 841 over 12. And then from there, the x-intercepts occur where y is 0 again. So we're solving for when this is equal to 0. So set it equal to 0. I'll probably use the quadratic formula in order to solve this. So opposite of b, plus or minus the square root of b squared. You don't need a negative because it's going to go away anyway when you square it. Minus 4 times a times c all over 2a. What's under the radical, if I simplify that, it gives me 841. So this would be 841. And then the square root of 841 is 29. So it would be 19 plus or minus 29 divided by 6. 19 plus 29 is 48. So I have 48 over 6. And then I have 19 minus 29, which is negative 10 over 6. And those should simplify to, let's see, it simplifies to 8 and negative 5/3. And those should be my two answers for x-intercepts. So the x-intercepts are at 8 and negative 5/3. Now the y-intercept, to find that, I want to, that's where on a graph, remember, that's where x is 0. So plug in 0 for x and you get negative 40. So that'd be at negative 40. This one ordered pair just wants the actual y-intercept is the y-coordinate. Okay, so the vertex is there, and then the x and y-intercepts.